Welcome to qnawire.
Newton's second law to the car, and then we can say that the buoyancy force is given by Archimedes' principle. So for part A, we can say that, draw the car. Going straight up would be the buoyancy force. This would be equal to the density of water multiplied by the volume of the car that is submerged multiplied by g. Going straight down would be the mass of the car times g, and we can apply Newton's second law. The sum of forces in the y direction would be equal to ma sub y. This would be equal to 0, and we have that the buoyancy force is equaling mg. This would be equal to the density of water multiplied by the volume of the car submerged times g. G's are going to cancel out, and we simply have that the volume of the car that is submerged under the water would be equal to the mass of the car divided by the density of water. And so we can solve. This would be equal to 900 kilograms divided by 1,000 kilograms per cubic meter. And this is equaling 0.900 meters cubed. Now, volume submerged divided by the volume of the object, this would be equaling, object meaning the car, this would be equaling 0.900 meters cubed divided by 3.0 meters cubed. And this is equaling 0.30, or we can say 30%. So this would be the percentage R that is submerged. So now we can then say for part B, when the car is to sink, it is fully submerged, and the buoyant force is equal to the weight of the car plus the water that is inside of it. So we can say that when the car is fully submerged, the volume submerged would be equal to the total volume of the car. And so we can say that the buoyancy would be equaling to the density of water multiplied by V multiplied by G. And so this is going to be equaling 1,000 kilograms per cubic meter multiplied by 3.0 meters cubed. And this would be multiplied by 9.80 meters per second squared. And so we can say that the buoyancy force would be equaling 2.94 times 10 to the 4th newtons. Now, the weight of the car, mg, would be simply equal to 900 kilograms multiplied by 9.80 meters per second squared, and this is giving us 8,820 newtons. And I can say that the weight of the car, the weight of the water inside the car when it sinks is the buoyant force minus the weight of the car itself. So we can say the mass of the water would be equaling the buoyancy force minus mg over g. This would be equaling 2.94 times 10 to the 4th newtons minus 8,820 newtons divided by 9.80 meters per second squared. This is equaling 2.10 times 10 to the 3rd kilograms. And so the volume of the water then would be equaling the mass of the water divided by the density of the water. And this would be equaling what we had just found, 2.1 times 10, 2.10 rather, times 10 to the 3rd kilograms divided by 1,000 kilograms per cubic meter. And this is giving us 2.10 cubic meters. This fraction then is of the total interior volume. So we can say that then 2.10 meters cubed divided by the total volume of the car, 3.00 meters cubed. This would be equaling 0.70, or we can say 70%. This would be our final answer for part B. the end of the solution. Thank you for watching.